So in this video, we'll be looking at the subtopic of deactivation of catalyst. So deactivation of catalyst means the catalyst is deactivate, means there is no more activity of the catalyst to run the reactions. So all this while, we assume that the activity of catalyst remains constant. Maybe in previous CHE502, we never talk about the activation of catalyst, right? What does it mean we never talk about? When we talk about the activation catalyst, there must be some kind of calculation need to be done. For example, here, the total concentration of active sites over time, we assume that it is what you call it, it is always it's always there, it's always activated, but the case is not. The catalyst has its own lifetime, in which that there must sometimes that the catalyst, due to different factors, the catalyst will be deactivated, and the activation of the catalyst would very unfortunate for most of industries and business operation. Let's have a look at the meaning of catalyst deactivation, what's the impact to the industries, and also lifetime of catalyst. Deactivation of catalyst can be defined as the loss of catalytic activity when the reaction takes place on the catalyst. So this is looks like this is the major problem faced by most industries, because the deactivation of the catalyst would strongly affect the conversion, and it will also affect the performance of reactor. So this actually would cause, the consequence is you have to maintain the catalyst, you have to do the maintenance on the catalyst activity. So when the maintenance has to be done, it will actually affect the costs. So it means that it's not economically beneficial to the industry. Therefore, if possible, the deactivation of catalyst has to be minimized actually. So in order to minimize the deactivation of catalyst, it has to increase the lifetime of the catalyst. So meaning that once the reaction has been decided from one industry, the industry also has to decide on what type of catalyst, because some catalysts will lose their activity for few minutes only, some last for more than 10 years. So of course the industry would prefer the catalyst that has lifetime which is longer, because it would give the beneficial on the economic performance of one industry. So generally, activity of catalysts, where is my cursor? Oh my god. Okay, generally the activity of the catalyst can be defined as a reaction rate of reactant A at time t over reaction rates of reactant A at time 0, means that initial reaction rate. So this is how activity of one catalyst can be quantified. Naturally, the activity of catalyst will degrade with time. So this is the typical curve for activity of catalyst. So let's say the y-axis is the quantifiable data of activity, which is A, small capital A, versus T. So we can look at here that the longer the time of the reaction, the activity will degrade. So this is the typical curve of activity of catalyst as a function of time. Several factors can cause the deactivation of catalysts. So some of the factors is because of unwanted chemical and physical changes, and these unwanted chemical and physical changes can be due to blocking of the active sites, and loss of catalytic active sites due to chemical, thermal, or mechanical process. So these are some of the examples that can cause deactivation of. So deactivation of catalysts, it can be from several ways. So in this courses, we define 3 ways that can cause catalyst deactivation, which is sintering or aging, fouling or coking, and also poisoning. So these 3 ways that can cause catalyst deactivation. Let's have a look at the deactivation of catalysts due to sintering, or the other name is aging. So the sintering happens of the catalyst with sintered, or sintering happens to one catalyst because due to prolonged exposure to high gas phase temperatures. And because of this, there will be agglomeration of crystal, or agglomeration of particles or metals. So kalau tengok gambar ni, initially the particles will be like this, but because of the agglomerated particles, it will goes bigger. So it comes bigger like this. So due to this, it will lose the catalytic activity, and also lost the active surface area. The other cause of the sintering of catalysts could be due to the physical differences of physical changes of pores inside the catalyst. So for example, initially the catalyst pores is like this, but due to the long exposure to high gas temperature, the pores become very narrower. So this could make the loss of active surface and would reduce the catalytic activity.